this is the chapter 7 internal forces, and we will do the diagrams of the shear force and the bending moment. The first step is to find the reaction force. Okay, so let's find the reaction force. Okay, so we have this 5 kilonewton in the middle. So we have two reactions. Vertical reaction, we don't have any horizontal reaction because sum of the forces equals 0. And if we solve because at the same distance, or we can also solve the moment about C. So we have 5 times 2, that is equal to NA times 4. So NA is 2.5 kilonewton and NC is 2.5 kilonewton. Okay, if it's in the middle, it's exactly half on both sides. And you can check that by doing the moment about A or the moment about C. Okay, so that's what the first step is. Second step, we need to find the interval where the function of the shear force and the bending moment will be different. So everywhere we have a force or a moment that is applied on the structure, we need to cut the interval. So it means that we need to use the first interval from, so that will be the axis x like this. So the first interval will be from 0 to 2, and the second interval will be from 2 to 4. Why? Because we have a force of 5 kilonewton there. Okay, so as soon as we have either a force or either a moment, we need to cut the function into different functions. So we determine the interval. So let's write that the interval 1 will be from 0 to 2, and the second interval will be from 2 to 4. Okay, so it means that we need to cut into this structure. So we will cut the beam between A and somewhere between, so that's X. Okay, that's my axis, X, and it's somewhere between 0 and 2. And the only force that we have, that we know, is 2.5 kilonewton. And now we will solve for the shearing force V at X and the moment at X and the normal force at X. We know that it's 0. Okay, we will not draw the graph there. So if we solve that, if we do sum of the forces on Y, it's equal to 0. What we find is that V, I call it Vx, but let's call V of x, it's equal to 2.5. So it's a constant. And if we do sum of the moment about, let's do about this point, about the point x, it's equal to 0. We find 2.5 times x, the distance in the negative directions, and the moment about x is plus, so plus mx is equal to 0. So we find that mx is equal to 2.5 times x. So we can write that between 0 and 2, the shearing force V of x is equal to 2.5 kilonewton, and the moment of x, so it's a constant, and the moment of x is equal to 2.5 x, and it's kilonewton time meter. So that's between 0 and 2. So now if we do between 2 and 4, okay, so let's cut there. Okay, we have our structure like this. So now the x is between 2 and 4. Okay, we have 2.5 kilonewton. We have 5 kilonewton that we know, and what we don't know is the new Vx. and the new max between 2 and 4. And we need some dimension. So this dimension there is x, and this dimension there is, so because this one is 2, okay, this is x minus 2. Let me think, the total x minus 2, right? So now let's solve for the forces. Sum of the forces on y, it's equal to 0. It gives us 2.5 minus 5 minus Vx, it's equal to 0. So V of x, it's equal to 2.5 minus 5, so it's equal to minus 2.5. And if we do sum of the moment about the point x, it's equal to 0. So about this point, that's my point x. We have, so 2.5, it's in the minus direction, so minus 2.5 times the total distance, that is x. This one is rotating in the plus direction, so plus 5 times the distance of x minus 2, and plus mx, it's equal to 0. Okay, so we have mx that is equal to, yeah, and we can call m of x, so it's equal to 2.5 times x minus 5 times x, and this is, so minus 10, but in the direction is plus 10. So the mx is equal to minus 2.5 times x plus 10. Okay, so let's write this there. So between 2 and 4, we have v of x that is equal to minus 2.5, and it's kilonewton. And the moment of x, it's equal to, we found, minus 2.5 plus 10. 2.5 x plus 10, and it's kilonewton time meter. Okay, so let's just see everything. Here we go. So this is the function of the shearing force and the bending moment between 0 and 2 and between 2 and 4. So now we can draw that. Okay, do I clean everything or do I draw? Let me draw on the top of that. Okay, so I will use the same. Okay, so I will make an axis there. This is my shearing force, and this one will be my moment. This is more shearing force, so that's V of x and M of x, okay, on top of each other. Here we go. Let me put this one a little bit like this. You will see why. So that's my V of x, and this is my axis x, and my axis x. Okay, so we need to do a function from 0 to 2 and another function from 2 to 4. Here we go. So we say that the shearing force between 0 and 2 is 2.5. So between 0 and 2, it's 2.5. And between 2 and 4 is minus 2.5. Okay. So what we see on this shearing force, and so it means that everywhere there from 0 to 2, the shearing force is 2.5. So you can solve at any point, okay? Any point there, if you get at any point, you will always find a shearing force of 2.5. And between 2 and 4, you will always find a shearing force between of minus 2.5. Okay, what you see, this 2.5 going up, this -5 going down and this 2.5 going up. Okay, that's those three forces. Let me draw it with this one. That's this one, and this one. So everywhere there is external load, external force, you must see a step in the shearing force. Okay, and in the same direction and with the same magnitude. Okay, now let's draw the moment. So m of x is equal to 2.5 x. So it means that for x it's equal to 0, m is equal to 0, and for x is equal to 2, the limit m is equal to 5. So the maximum of the moment is 5, and it's increased like this from 0 to 2. Okay, that's kilonewton time meter, and this one is kilonewton. And this one, so for x it's equal to 2, it's the moment is equal to minus 2.5 times 2 plus 10, and it's equal to minus 5 plus 10 is equal to 5. Okay, and you find the same answer. You need to define the same answer because we do not apply an external moment. Okay, so the moment should be continue. For x is equal to 4, the second like the last limit, like the C, at the point C, we have the moment that's equal to minus 2.5 times 4 plus 10, and it's equal to 0. So the moment is there. Okay, so that's the function, the graph for the moment for any point on the beam from 0 to 4. Okay, so from 0 to 2, the function is 2.5 times x, and from 2 to 4, the function is minus 2.5 x plus 10, like this. Okay. So what we can see now, you think this is 2.5 and this is minus 2.5. Okay, those 2.5 and 2.5, they are the same, and this one is the same. Okay, so this is the slope and this is the constant. Okay, do you think about something when we say that? If we take the derivations, so if we take the derivation of 2.5 times x, okay, it's equal to what? 2.5. If we take the derivation of minus 2.5 times x plus 10, we take the derivation of this about x, it's equal to minus 2.5. Okay, so the shearing force, it's equal to the derivation or the derivative of the bending moment. Okay, and in the opposite direction, we can say that the bending moment, it's green now, I don't know, it's fine. The bending moment is equal to the integral, or yeah, integration of the shearing force. Okay, when the moment is increasing, the shearing force is positive. When the moment is decreasing, the shearing force is negative. So that's your graph. So let's go back to the steps. Let me try to move that. Oops. Here we go. Here we go. We have all the steps in this video. Oh, this one is the next problem. Forget about this problem. That's for the next questions. Here we go. So step 1, reaction force. Step 2, we solve for the internal force for each interval. Okay, and how do we determine the interval? It's everywhere we have an external load, or it could be a force or a moment, an external force or an external moment. We need to make a new interval. And third, draw the graph or function. So use the function. You can use your calculator too to draw the graph. So you should enter one function for the axis between 0 and 2, one function for the moment of axis between 0 and 2, one curve for the shearing force between 2 and 4, and one curve for the moment between 2 and 4. That's four of them, and you can check. So that's it for this first example. This lecture is just basically example that I will do, like three little examples. See you in the next video. Bye bye.